In this video, we're going to be looking at point-slope form. Our objectives are to understand how we got point-slope form and to understand how to make a linear equation in point-slope form. Our vocabulary is point-slope form, linear equation using the slope and any point on the line. It looks like this: y equals y1 plus b times the difference of x minus x1. So the first thing I want to do is I want to show you how we create point-slope form. So anytime we have a big division bar like this in slope, this bottom here is really in parentheses. Well, what we want to do is we want to get the y by itself. Well, we really only need one point, so what we're going to do is we're going to call this just x and this just y, and these are going to be our typical variable in the problem. x1 and y1 will be numbers will be put into it that we're going to actually utilize a little bit differently than other problems. So what we want to do is we want to get rid of this bottom. Well, we're dividing by this whole bottom, so if we multiply by it, notice I've used the balance method. I've multiplied on both sides. These cancel out. We're left with y minus y1 equals b times x minus x1. Okay? So now we want to get this y by itself because that's typically how we see our equations. So we're going to add y1. These will cancel. We get y equals b times x minus x1 plus y1. Oops. And this x and y1 are just any point that's on the line. These x and y's here are our typical x and y in any equation. This isn't typically how we write it. Usually we put the y1 in front because addition doesn't matter, the order. So this is typically how we see it. And this is point-slope form. Notice it has everything from slope in it. X minus x1 is there, the y and the y1 are there, and then the b. Okay, the next thing that we want to take a look at is just basic, what is point-slope form? Well, our x and our y here are just our typical x and y. This plus b is our slope, and our y and x here are any point on the line. Now, one of the advantages of point-slope form over intercept form is you can use any point on the line. In intercept form, you have to have the start value. So if I don't have the start value, I can't really make an intercept form. But if I have some other point on the line that's not the start value, I can make point-slope form. So I'm going to show you what that would look like, just as an example. So there are many ways that this can look, but here what we're going to go with is just 2 points that we're going to work from. Negative 1, 4 and 2, 5. Notice neither of these is a starting value, so intercept form isn't going to work very good. So what we need to do is we need to work off of point-slope form. And we're actually, the nice thing about this is there are many answers that work. So we're actually going to have 2 from this problem. So the first thing we need, since it's point-slope form, is we really should start with the slope first, because the slope is pretty important. So we have our slope formula. Okay, so x, y, negative 1's smaller than negative 2, or than positive 2, so this one's going to be my 1's, this one's going to be my 2's. Okay, so y2 gives us 5 minus y1 of 4. x2 is 2 minus x1 of negative 1. So what we're going to get here for slope is 5 minus 4 is 1. 2 minus negative 1, so that's really plus there. So that's going to be 3. So we have a slope of 1/3. And that can't be reduced, so we're going to use 1/3. So then what I do with my equation is I just pick a point and I use my slope. So this first situation, we're going to use the first point. So I still need y. y1, well, y1 is 4, so I'm going to put a 4 in. I have a slope of 1/3, so since it's positive, it's going to be plus 1/3. X has to stay in the problem. Minus x1 was negative 1, so we're going to put in negative 1, and there's our answer. Now this can be written a little bit better because minusing a negative is really just adding. So I'm going to erase this and write it as a plus sign instead of minus negative 1. So this is one option. Option number 2 is to use our second point up here. So I'm again going to start with y equals, and we've got y1. Well, this time we're going to use y2, and that's 5. Our slope doesn't change between the two of them. It's still 1/3, so plus 1/3. X stays. We're going to subtract x1, which in this case is x2. So minus 2. These two problems are both acceptable in this situation. They're actually the same problem, just written a little bit different way, because both points are supposedly on our line. Okay? If there's any part of this that you didn't understand, please pause, rewind, rewatch, and bring any questions to class. Thank you.